This is Module 3, Lecture Note 6. You will just need your printout of your lecture notes. And then if you could grab your periodic table that we worked on last time, that will be very helpful for the second page of these. Today we're going to talk about the difference between atoms and molecules or compounds. Okay, an atom we're going to define as the smallest chemical unit of matter. Okay, so an atom is the smallest chemical unit of matter. Everything is made up of atoms, which, if you really think about it, is pretty cool. The pencil that you're holding or the pen is made up of individual teeny tiny little atoms. This paper is made up of atoms. My nail polish is made up of atoms. Your hair is made up of atoms. I once looked up that a hair has about 100,000 atoms for its width. So a hair has 100,000 atoms across it. And that's crazy. That's a lot of atoms. So that must mean that atoms are really, really small. Okay? There was a guy a long time ago named John Dalton, and he came up with 4 theories or 4 important points about atoms, and they composed his atomic theory. Okay, so let's go through these and make sure you understand what he's actually saying. The first one says that all elements are composed of atoms. So he's saying that these elements on the periodic table are composed of individual atoms. Okay, so oxygen would be made up of oxygen atoms. Fluorine would be made up of fluorine atoms. And that plays into this second one. All atoms of the same element have the same properties. So all oxygen atoms are going to have the same atomic mass. They're going to behave the same way. They're going to be identical if they are of that same element. Atoms of different elements will have different properties, and that makes sense. We would expect helium atoms to be different than those of oxygen or fluorine or chlorine. Okay, so these are some points that he made that make sense when we go through them. And then the fourth one talks about what happens when atoms join together. Okay, so that would be a compound when one or more atoms join together. And they join together in whole number ratios. And we'll talk about that later on. But these 4 points are important to know and know how that we're going to apply those here in this unit. Okay, so an atom I like to think of as just a single thing. But a molecular compound is when a group of atoms join together. So we'll say groups that form when atoms join together. Okay, I like pictures because it helps us visualize things sometimes more than words do. Let's draw the difference between an atom and a molecule. Okay, so let's label this one atom. And we'll call this one molecule or compound. Those words are kind of interchangeable. Okay, we said that an atom is just something by itself. It's the smallest chemical unit of matter. So let's draw some hydrogen atoms. Notice that I'm drawing these hydrogen atoms all the same. I'm trying to at least. Drawing them like each other because remember, atoms of the same element have the same properties. So these might be hydrogens. If I wanted to draw a different element, maybe I wanted to draw oxygen, I would need to draw it differently than hydrogen because it's a different element. So these are my oxygen atoms. I'm going to put a little O above them. We can make them look different. Okay, but the thing to notice here is that atoms are separate from each other. Now, if we jump over to this box and we want to make a compound or a molecule, atoms need to be joined together, and they are going to be joined chemically. And that's done by bonds. So joined, we'll say these are separate. Okay, so let's join some oxygen to hydrogen and let's make a water molecule. Okay, water is H2O, so we need 2 hydrogens and 1 oxygen, and they're joined together with bonds. Okay, we can call this H2O or water. Okay, so I hope that helps you see the difference between atoms that are separate, molecules or compounds that are fused or joined chemically together. Elements have names and symbols. Okay, and I think you know that because you've done quite a bit with the periodic table. Elements you're going to find on the periodic table. They have a name and a shorthand symbol. And I'll just write periodic table here to remind you that that's where we find all of our elements. Okay, well, molecules have names too. They're not on the periodic table, but they do have names. Some of them have common names like water, H2O, because it's something that's very, very common. But we're also going to learn later in this lecture how we can name molecules using a naming method. As you are reading through this unit, you probably noticed that they touched on the law of mass of conservation, or the law of conservation of mass. This is very, very similar to that first law of thermodynamics. It says matter cannot be created or destroyed. It can just change form. And that's very similar to energy not being created or destroyed. It just changes form. Okay, and here I gave you some examples. If you take a piece of wood and you burn it, it's going to change into a different form of matter. Maybe it changes into a gas like carbon dioxide. Some water vapor goes up into the air, and then you're left with the ashes in your fireplace. The matter didn't go anywhere. It didn't disappear. It just changed into a different substance. Okay, you will see a couple conservation of mass problems, and I wanted to work through one with you so you know how to do them. They're pretty simple and they're kind of all the same. It says a chemist decomposes. That's a fancy word for break down. He decomposes 150 grams of water. So I'd like you to put 150 grams of water. We're going to break that down or break it apart. So let's draw an arrow. It says he's able to make 16.7 grams of oxygen, but we don't know how much hydrogen was produced. We do know that hydrogen and oxygen form water. So we could just do some simple math and our conservation of mass law to figure out what must be left. If we started with 150 grams of water, we still have to end up with 150 grams of something. It doesn't just disappear. It might have broken apart into 2 different elements, but when we add these back together, we should still have 150. Okay, so all you're going to do is you're going to take 150 minus 16.7, and you'll get your answer. I guess you might need a calculator. I'm sorry, I forgot to say that in the beginning. So you'll take 150 minus 16.7, and I get 133.3 grams of hydrogen. And that would be your answer. Okay? Another skill that you might need to know in this unit is how to form a molecule out of separate atoms. Okay, so you may see some problems where they say, I have 2 lithium atoms, 1 sulfur atom, and 4 oxygen atoms. Put those together, and how would I write that as a molecule? Okay, all you're going to do is you're going to put the symbol for lithium, and the way that you say that you have 2 of lithium is you put a little subscript, 2 lithium. It says we have 1 sulfur. You do not need to put the subscript 1. It's kind of just implied that if I have an S, there's 1 of them. And I have 4 oxygen, so I put O4. So all you do is take the proper element symbol and then tell how many from the problem using subscripts. So that's how you would write this as a molecule. And you can also do that in reverse form. If the question asks you how many of each atom, you just need to dissect this back into the individual elements. So you should know that Na is sodium, and we have 3 of them. What's P? Phosphorus. And because there's no number after phosphorus, I would assume I have 1. And oxygen, I would have 4 of. So that's how you will do those type of problems when you see them. The most important part of this lecture and this part of the unit goes back to our periodic table and how to classify, and now we're going to learn how to name ionic and covalent compounds. I always tell my students every year, if there's one thing that you could get really, really good at in first-year chemistry, it would be to name ionic and covalent compounds. Once you get the hang of it and you practice it and you get really good at it, that is a skill that will stick with you throughout all the other units that we're going to study this year. And it will carry into college science if you take that. But everything kind of comes back to these molecule and element names. So please, please, please do your best to take good notes, practice, ask questions if you don't understand. But this is a foundation in chemistry that you cannot let pass you by. Okay? All right, so this first part is a review from our lecture last time. We said that ionic compounds have metals and nonmetals in them. They have 1 from each side of the periodic table. And remember, covalent is when you have only nonmetals or metalloids. Okay, I'd like you to pause a second and do these 3 problems as a quick review, and then come back and check your answers. Here's what I got. For calcium with bromine, that's going to be ionic because they're on opposite sides of the periodic table. Silicon and fluorine, they're both over here. We have a metalloid paired with a nonmetal, so that's going to be covalent. And then I threw in water again to make sure you don't forget hydrogen up here is a nonmetal. So hydrogen, oxygen are both nonmetals. That would be covalent. Okay. So now we're going to learn how you assign names to these. But the first thing you have to really know is if it's ionic or covalent. So that's why we reviewed this part. If you decide something is ionic, you are going to name the first atom, and then you're going to add "ide" to the end. Okay, so let's practice this. K is potassium, and O is oxygen. So this would become potassium oxide. You drop the ending on oxygen and you add "ide," potassium oxide. And it should sound good, okay? I also want you to note that you ignore these little numbers. for ionic naming. Oops. Okay, you just simply use the elements and you don't worry about including these numbers as part of the name, potassium oxide. All right, you try the next one. Leave the first word alone. Add "ide" to your second element, sodium chloride. Ionic are pretty simple. Let's move on to covalent. If you know something is covalent, like these that have only nonmetals, you're going to use prefixes to tell how many there are. Okay, these prefixes you need to memorize. Memorizing something else, oh no. But actually, if you look through them, they're pretty simple. Mono means one, di means two, tri, like a triceratops or a triangle, we know means three, tetra, four, penta, pentagon has 5 sides, hexa, 6, hepta, 7, octagon, 8, nona is 9, and deca is 10. So a lot of these I think will be pretty easy to assign to your memory. You might need to review these last ones, but you will be expected to know these when you are naming compounds on a quiz or a test. Okay, so let me show you how this works. I need to tell how many carbons we have, and so I do that by using the prefix di, because there's 2. So this would be dicarbon. I have 6 hydrogens, so I would use the prefix hexa, hydride. Okay, you're still gonna use the ending "ide," just like we did with ionic. Okay, let's move on to carbon. It says if there is only one of the first element, like we have here, you don't need to use mono. It would sound kind of redundant. CO2, we know, is carbon dioxide. We don't say monocarbon dioxide, we just say carbon dioxide. So that's where this first rule comes from. Carbon, there's only one of them. There's 2 oxygens. So that's where I get dioxide. Okay, but what about CO? I only have one of the first element, so we said we don't need to use the prefix mono. For the second element, if there's only one of them, that is where you use the prefix mono. This is carbon monoxide. Okay, you could put monoxide if you want, but technically you don't need to have 2 O's next to each other in the writing. Carbon monoxide, and I'm sure you've heard of that compound too. That's where its name comes from with our naming sequence. I'd like you to try pH3 on your own. See if you can get it using the rules that we've just talked about. Okay, you should have come up with phosphorus. There's only one of them. Trihydride. There's 3 hydrogens, so you use trihydride. Okay, so that's how you name ionic compounds and covalent compounds. You first need to know what it is, then name it properly. Okay, let's see if you really have the hang of this. Please go ahead and fill out the names for these 2 compounds. One is ionic, one is covalent. You need to figure out which is which and then name them accordingly to the rules that we just talked about. All right, so here's what I came up with. I like to decide if it's ionic or covalent and put an I or a C next to the problem so that I know what I'm doing. I decided that rubidium sulfide was ionic because rubidium's a metal and sulfur's a nonmetal on the other side. So I know that when I name it, I don't need to use the numbers as part of the name. I simply call it rubidium sulfide. For my second one, it's covalent because both phosphorus and oxygen are nonmetals. So I do need to use prefixes to tell how many. I have diphosphorus trioxide for its name. Okay, so definitely practice this on your homework, get the hang of it, get really, really good at naming these. I promise you will be seeing naming lots and lots throughout the units that we go through, and having this under your belt will make everything else so much easier. Trust me. Okay, work on memorizing these this week. I think you'll use them a lot and they'll kind of be assigned to your memory as you practice your homework with them. Thanks for listening.